Okay, so this is the fifth chapter of Year 13 Mechanics, and it's about friction. So we're going to start off actually doing something different called resolving components. This is going to be really a key foundational skill that you're going to have for the rest of mechanics. And then we're going to start looking at inclined planes. That's picture, for example, that's the kind of thing we're going to be looking at. And then we're going to move on to sort of understanding how we're going to handle friction in a slightly more sophisticated way, rather than just being given fixed values, being able to work this out and sort of work out how this affects what happens or doesn't happen. So the first section, as I was sort of saying, is about resolving forces. So what do I mean by that? Well, if you imagine like a lead on a dog pulling up like this, what's that really doing? Well, in that, there is some going to the right and there is some going up. And remember the addition rule with vectors, sort of the way I've drawn it there. It makes the diagonal when you join the arrows up. So when you pull a dog like this, you're pulling the dog up slightly and you're pulling the dog perhaps towards you slightly as well. So let's go a bit further with this idea now. So over here, I've given the force a number, which is 60 newtons. So the diagonal arrow is 60 newtons. And I've got the number here, 40 degrees. So this force is exerted at 40 degrees to the horizontal. So I want to now find out how much of that 60 newtons goes into the horizontal amount and how much goes into the vertical amount. And the way we're going to do this is we're going to make a right angle triangle. So I use my dotted lines like this. I've got my 40 and I've got the hypotenuse, which is 60. So which bit of maths links together a right angle triangle with an angle and the hypotenuse and another side that you want to work out? And here, let's start with the opposite side to begin with. Well, it's SOHCAHTOA. So if I take the sine of an angle, that includes the opposite side and the hypotenuse. So let's write that out. So sine of an angle equals the opposite over the hypotenuse. And if I put some numbers into that, sine of 40 is going to be equal to the side that I'm trying to find out. I'm just going to leave it as a question mark for now, over 60. Or in other words, the amount, if we rearrange this now, the amount that is vertical is 60 sine 40. Okay, so that is the sort of the vertical element of it. And you can work that out, 38.6. I'd prefer to leave it as 60 sine 40 because you might have to do some manipulation with it later, but that's what you would get. How about the adjacent side now? How about this side? Well, we're going to do the same thing. So I would have the hypotenuse and angle, but I'd have the adjacent this time. So what links the adjacent and the hypotenuse in a triangle? It's cos. So if we try writing out a cos statement, so cos 40 equals, I'll just write ADJ for adjacent over the hypotenuse, which is 60 again. So 60 cos 40. Okay, and if you work that out, that's 45.9 newtons. So they don't have to add up to 60. That's not how it works. But you do end up with the opposite side. So the opposite one to your angle is going to be the sine one. And then the one that's next to it will be the adjacent one. It's the cos one. So you're going to see lots and lots of something sine something, something cos something. And look for the similarities. So 60 sine 40, 60 cos 40. So you'll be using the angle twice and the hypotenuse twice as well. One will be sine, one will be cos. And there's a slightly neater version of it written out there for you. So let's do another one, resolving the forces. So this one, they haven't drawn the triangle yet. So let's draw the triangle. So you want to make it at like a right angles to the vertical or the horizontal axes, what they would normally be. So what do I mean by that? I mean, you want to draw your right angle triangle like this. Okay, some people struggle with that when they first get started. The 60 is that part there. And can we do that bit quickly now? So 400 is the hypotenuse. So what links the opposite and the hypotenuse? That's going to be sine. The opposite one is sine. So it will be the hypotenuse number. Think about the pattern on the one before. It will be the hypotenuse number, which is 400. Then it will be sine, and then it will be 60. So this one will be 400 sine 60. So when a force is going this way, 400 sine 60, that's the amount that's going down. Now, I don't have to draw the down arrow underneath it. I could, but I'm not going to do that. So 400 sine 60 goes down. And the adjacent one then, well, the adjacent one over here is going to be 400 cos 60. So yeah, they've drawn kind of the same thing. And as you see underneath, they've put the numbers there if you choose to work out what they are. Okay, a little bit more practice. Let's speed up a little bit now. So again, we've kind of got one of these done for us already. So the opposite side, this one is 5m. So the m, we don't know, could be an unknown, or maybe it might be a distance. You might remember in chapter 4, we resolved distances. Whatever it is, it's the same process, okay? I'm just going to treat it as a distance. I'm going to ignore m for meters. And I'm going to say then that would be 5 sine 60. And the other one here, well, this is adjacent, so this is going to be 5 cos 60. Over here, opposite is slightly different. So opposite first is going to be 7 sine 60, and adjacent is going to be 7 cos 60. Okay. You could do all sorts of other things with these if you wanted to. One thing that's quite interesting is, and that's discussed here at the bottom, is if you find the magnitude by sort of treating this bit as the I bit and the J bit. So if you square them, add them together, you'll find that it does satisfy Pythagoras' theorem, and it will take you back to 5. Okay, so if you had lots of time on your hands in the exam, you can check that you've got the answers correct as well. Okay, a few more quick questions. Let's have a look. So opposite sine, adjacent cos. If you wanted to write it in vector form with I and j, you could do that, couldn't you? So this one here, so cos 30, remember, is root 3 over 2. If you do 8 times that, you end up with 4 root 3. Sine 30, remember, sine 30 is a half. So that's where you get 4 from. Number 2, 45, 6 newtons. So opposite, adjacent, and again, if you wanted to, you could put that into vector format. Remember, with vector format, vectors have a direction. So if it's left for I, it would be negative. And if it were down, it would be negative for j. But it's not because it's up in this case. One more. So here, what we would do is we would do something like that to get started. And 9 sine 37 is opposite, which would be this one. And then cos here. And again, I and j, well, I, you can see the direction there would be positive. If it's going down, you have that negative there. Let's go a little bit further with this now then. So we can start talking about force diagrams and building what we did in year 12. So I've got a block here. I've got 3 newtons coming from it at 45 degrees to the horizontal. What could you do with this? Well, because you're going to have lots of forces in the diagram that are vertical. So remember, that would be R. And then the weight from the block would be 10g. Because you've got vertical forces and you'll often have horizontal forces, it's very useful to turn this diagonal one into horizontal and vertical as well to match the rest of the diagram. So we're going to turn that one into something like this. This is a bit like that lead, pulling the dog on the lead earlier. So opposite would be 3 sine 45, and adjacent would be 3 cos 45. Once you've done that, I tend to just sort of get rid of the diagonal, just because I've resolved that now, so I don't want to double count things. And then on my diagram, if I need to, I can work other things out. So do you notice now that I have 1, 2, 3 vertical forces? So if I'm told that this is an equilibrium, I can start to make some equations. So all of the up forces must be equal to the down forces, or the resultant is 0 if you prefer to think of it that way. So R plus 3 sine 45 would be equal to 10g. So I could do something like that. How about the 3 cos 45? Well, we don't really know about that yet. Maybe it's accelerating and there's no force the other way. Maybe there's friction. The friction bit, remember, is later in the chapter. So I'm not going to worry about that too much for now. But there we go. We can start doing something like this. The one on the right-hand side, I'll give you just 10, 15 seconds to, first of all, pause the video and have a think about what that would resolve into. And if you can, try doing it without writing out the sine theta, cos theta, the whole thing. Try thinking about the pattern we've been using. Okay, so something like that. And as I did on the diagram in the left, actually, the 10g could be drawn here, should be really. And you could do the same thing there. And in this diagram, if we're told that it's an equilibrium, which seems reasonable that it's on the table, you could work out the R force if you wanted to. Notice it's a bit more complicated than just saying R equals 5g. That's not true. It's R plus 14 sine 23 equals 5g. Let's do another example. So we've got a little bit more detail going on with this one. A box of mass 8 kilograms lies on a smooth, that's important, it means there's no friction, a smooth horizontal floor. A force, and I'm going to cross that out because I can see that already. A force of 10 newtons is applied at 30 degrees. Right, I'm going to cross these things out because I can already see them on the diagram. Causing the box to accelerate. So if something's accelerating horizontally, it will mean that the horizontal forces are not balanced. The resultant is not 0. So the first part is work out the acceleration. But what we want to do first is we want to turn this into a diagram where everything is at right angles to each other. So what I mean by that is typically, but not always, you've got up, down, left, right. I say not always, and you'll see why later in the chapter. Okay, so we do our right angle triangle like this. And remember, it's 10 sine 30, which actually just happens to be 5 because it's half of 10, and 10 cos 30. Okay, we could also draw on the 8g, the reaction force, as it says it's on a floor. So a floor will give a reaction force, and that's all we were told in the question. So a neater version would look like that. Work out the acceleration. Well, it's implied when they say acceleration here, we're talking about the horizontal acceleration from before. So you only want to, for part A, be talking about the horizontal stuff. Okay, it's completely separate to the vertical. They are completely separate. So if you're told that something accelerates, a good first step is often to write F equals ma. Write out the resultant force, always the resultant force, horizontally. Well, there is only one force, which is 10 cos 30 in this case. There's nothing else to write with that one there. M is 8, and A is what we're trying to find. So that's the equation that we need to solve. And there's your answer there on the screen. Better to leave things in exact form typically. Cos 30 is root 3/2, so you can get that result there. Right, what's next? Calculate the normal reaction between the box and the floor. Yep, that will be R then. So they want to know what R is. Two choices of how you can answer this question. And this is really a very, very big theme that we're about to talk about. So when you know that the forces are balanced, because, well, if they weren't, it would be accelerating upwards or it would be accelerating downwards through the table. So when you've got these situations, when vertically it's in equilibrium, okay, so we can use the word equilibrium for the vertical part, you can either do up equals down, if you like, or you could do the resultant equals 0. They are the same thing. Okay, they are the same thing. Up equals down. Why can I be so sort of flippant about that? Well, it's because we would be using F equals ma, but if it's not moving, if it's not accelerating, then this is 0. So the whole right-hand side is 0, which means the left-hand side is 0. So that's really where this comes from. So half of mechanics for A-level is more or less F equals ma. So F equals ma is very obvious when you're told that something is accelerating, but this idea of up equals down, left equals right, up equals down, left equals right, that's really just a manifestation of the same idea. Okay, so I'm going to just say up equals down. So all of the up forces equal all the down forces. So up force. Any more up forces? Yes. 10 sine 30. Remember, this is the same as 5. Okay, so plus 5 equals all of the down forces, 8g. So there you go. You can get the R on its own, which is just 8g minus 5. Okay, and that should be 73 newtons. Okay, combining forces. So resultant, remember that resultant means the overall thing. So overall in this context might have been about left and right and up and down, but overall can apply for when things go in the same direction here. So do you see that P and Q, for example, both go to the right? So we can work out what they are and just add them together. For up and down, notice they work against each other for up and down. So I'm going to do my triangles as before. Maybe we'll just go like this. So for P, I've got, well, I don't know what it is. Let's read the question. Two forces, P and Q, act on a particle. P has a magnitude of 10. There we go. And Q has a magnitude of 8. There we go. Work out the magnitude and direction of the resultant force. Okay. Yeah, and magnitude and direction, they're pretty much as standard. Want you to find the resultant first in these questions. But yeah, here it's spelled out for us. So for up, what have we got for up? We've got 10 sine 45. What have we got for P to the right? We've got 10 cos 45. How about for particle Q? So let's do the down part first. So for the down part, it's 8 sine 30. And for the part to the right for Q, it's 8 cos 30. And all you've got to do then for up and down is, well, for up and down, you want to find the resultant out of these two. And for horizontally, you want to just find the resultant of these, and you'll do that by adding it together. Okay, so there we go. Horizontal, adding them together. Vertically, they've started with P, so they've done P minus this. So that one will be the bigger force. And you get this result here. So that's your resultant force. Magnitude, we're going to do Pythagoras with this information. And for the angle, so tan, okay? Because I's and J's will give you your opposites and your adjacents, as you've kind of seen already today. So you can just put that information on a triangle and find your angle. And it doesn't say anything that specific about the angle. So I suppose we just go with 12.4 on this occasion. I'm not going to go through this way of doing it because you really don't need to do it that way. So final question, give it a read. So pause the video, have a go. And you should have found that you created sort of 4 different numbers, a sine and a cos for each of these. And just be careful because it's about vectors, that to the left would be negative, for example. Up would be positive here, right would be positive, and down would be negative. But you should get the results, and it's the same steps as before. So you're now ready to have a go at the exercises related to 5A. And really the theme of what we've been doing here is resolving forces, okay? They're measured in newtons. You want to find the horizontal and vertical components. Doing this quickly, opposite being sine, adjacent being cos. Use right-angled triangles, and be careful that you're putting the right angle in the right place. Shortcuts sort of as follows. Over to you.